In one of our Math 7 sections today, we had a rushed finish. So I do want to just go over this basic idea of multiplying more than two integers at a time. After we experimented with the checkers last week, we saw that if we multiply a negative times a negative, it equals a positive. A positive times a positive is equal to a positive. And a positive times a negative is equal to negative. And a negative times a positive is equal to a negative. In other words, same signs equals a positive, and different, and don't forget, this is not the same as when we're adding, different signs equals a negative. But I was careful to tell you that this only works when we're multiplying two numbers at a time. Here's the reason why. Let's just extend that. Let's say I have negative 2 times negative 3. We already know, because we did this before, that that gives me positive 6. If I then multiply that by negative 2, I get negative 12. These are all the same signs, but it gives me a negative answer. And that's because these two negatives made a positive and left one negative left over. What if I then multiplied this by negative 1? Well, this whole thing, negative 12 times negative 1, then makes it positive 12. And what we can see here is that any two negatives make a positive. I once had a student say, there's one negative, another negative turns it to a positive. There's one negative, another negative turns it to a positive. And you can see that if I have an even number, so basically what you want to do is count the negative signs. The positive signs don't matter because they don't change anything. I already know from years of working with math, a positive times a positive times a positive times a positive, that's always going to be positive. The only thing that matters are the negative signs because it sort of reverses the direction. So count the negative signs. An even number of negatives, I'm going to use that little symbol, of negatives equals a positive, and an odd number of negatives equals a negative. So let's just think of some outrageous numbers. Negative 150 times, 15, I'll leave it at 15, times negative 72 times 30 times negative 20. Okay? I don't even know what those numbers are going to multiply to equal, but I can see that I have 1, 2, 3 negative signs. That's all that matters. 3 is an odd number, so therefore the sign will be negative. If I say 2 times 5 times 3 times 7 times 4 times negative 2, I have one negative sign. Actually, let's make it two negative signs. Say negative 3. So a negative 4. So I've got two negative signs. An even number of negative signs is positive. All right, so just count your negative signs. And extend this understanding to what happens when I raise negative numbers to powers. So let's just say negative 2. Negative 2 to the second power. We know that if we open that accordion and expand it, that means negative 2 times negative 2. I have 2 negative signs, and therefore it equals a positive 4. 1, 2 is an even number, and an even number of negatives make a positive. If I raise it to the third power, That's like saying that I've got an odd number of negatives. So 2 times 2 times 2 is 8, and 1, 2, 3 negative signs. 3 is an odd number, and therefore my answer is negative. So from that I can conclude, a negative number raised to an even power equals a positive, for the very same reasons that we saw with multiplication. A negative number raised to an odd power equals a negative. So, most of the homework problems that you need to work tonight are just straightforward application. A little bit into them, they get somewhat more complex. For example, if I take the problem 4 times negative 3 squared. Well, for one thing, I can see that there are 2 steps here because I have both multiplication and exponents. And if you remember GREMDAS, which hopefully you do because it's still going to be in play forever and always. And I'm going to put my little arrows over there to remind you that we're doing multiplication and division from left to right, as well as addition and subtraction. So these are not grouping symbols because there's nothing going on inside. Therefore, our first step is exponents. If I have a negative number raised to an even power, that makes it positive. 3 squared is 9. Negative 3 squared is also 9 because it's an even exponent. I just bring my 4 down and now I multiply, and 36. I get 36. In a problem like this, you must show 2 steps of work. Just like what I did here. Step 1 was the exponent. Step 2, so this was step 1, and then step 2 was the multiplication. So there are some that are like that. There are others where it might say A is 2, B is 3. I don't know. And let's just leave it like that. And it might say, no, let's make 3 negative. A, B squared. Okay? So remember, you have to show replacement. Sorry, I didn't have quite enough room. And then follow GREMDAS. Okay, so showing replacement means that where there's an A, I plug in 2. Where there's a B, I plug in negative 3 squared, because this is B squared. And just like the problem before, I have to first do the exponent and then the multiplication. Beware, don't do A times B and then square it. It's only the B squared. So, good luck with these problems. It's all very interesting.